is day 1 of rational exponents and radicals. We are splitting this up into 2 days because it's kind of a long set of notes. So starting with what the nth root of a number is. So if I raise b to the nth power and my answer is a, the nth root of a, like if I took the nth root of a, my answer would be whatever that number b was. Okay, so the root refers to the answers. So in a square root, you would have 2, the positive and the negative. You could have the cube root, 7th root, etc., depending on what this number in front of your radical is. So 7 squared is 49. That means that 7 is a square root of 49. 24.5 squared is 600.25. That means that 24.5 is a square root of 600.25, and so on. 4.2 to the third power is 74.088. So 4.2 would be a cube root. It matches the exponent of 74.088. 6 to the fourth is 1,296. So that means that 6 would be a fourth root of 1,296. 45 squared is 2,025. So 45 is a square root of 2,025. 12 to the third power is 1,728. So that means that 12 is a cube root of 1,728. Okay. Now the principal root is the root with the same sign as what's inside our radical. So if a is positive, then the nth root is positive. If a is negative, then it's negative. So the nth root of a, n is our index, so that number in front of the radical, and it's always a positive integer, and a, what's inside the radical, is called the radicand, and that can be positive or negative. So starting here, my radicand inside the radical is positive, so my principal root is going to be positive. So the principal root would be positive 3. Okay. Now the cube root of negative 8, it's negative 8 in here, so that principal root is also going to be negative, and that would be negative 2. Okay. Moving on to the next page. Properties of nth roots. So if a is a positive real number and n, that number in front, is even, then it has 2 real roots, the positive or the negative. So for example, 3 squared and negative 3 squared both give you a result of 9. So 9 has 2 roots, 3 and negative 3, but remember the principal root would just be the positive value. Okay. If a is a real number and n is odd, then it only has 1 root. So when we have an even number root, so square root, 4th root, 6th root, etc., we get the positive and the negative. If we have an odd root, so 3rd root, 5th root, etc., we only have 1 possible answer, and that's because a negative times, I keep writing 1, a negative times a negative is always going to give you a positive. I apologize about that, Belle. A negative times a negative. So when you're squaring a value, that gives you a positive number. But when you're cubing a value and you get the negative 3 times, that's going to give you a negative answer. Or if we did positive 3 times, you're going to still have a positive answer. If we have an odd root, it's going to match the sign of whatever's inside your radical. So the cube root of negative 8 is negative 2, and the cube root of, the 5th root of 32 is going to be positive 2. If a is a negative number and n is even, then it has no real root. So like the square root of negative 9, there's no solution. Same thing for the 4th root of a negative number. Okay, so even roots, 2, 4, 6, 8, etc., you have the positive and negative root. Odd roots, 3, 5, 7, etc., you have the single root. It matches the sign of what's inside your radical. Even roots, you can't take the negative of. No square root, no 4th root of a negative number. Okay. We are now going to state the index, radicand, and give our principal root for the next couple problems. So remember, the index is the number in front of your radical. So the index here is 3 because it's a cube root. Your radicand is what's inside the radical. And the principal root, remember, matches the sign of whatever is inside your radicand. Oh, what is your radicand? So it's positive, so our principal root is going to be positive. The cube root of 125 is 5. Okay. Index 4, radicand 16. The principal root, it's going to be positive, and that would be 2. The index is 2. If we don't have a number there, remember we're assuming it's square root, so that would be 2. The radicand is what's inside, and the principal root, we're going to match the sign, is positive 12. Index 3, radicand negative 64, which means our principal root is going to be negative 4. The index is 4, the radicand is negative 1, and we can't take the even root of a negative number, so that would be no solution. Okay. Then if we have the fifth root of negative 1, that's going to be negative 1. We can take the odd root of a negative number. The last thing we want to touch on today is perfect squares and perfect cubes. So those are numbers that have integer square roots, whole numbers. So 25 is a perfect square, 4 is a perfect square. Perfect cubes are numbers that have integer cube roots, whole numbers. So 8 and so on. So the roots of these perfect squares or cubes are rational numbers, whole numbers. And the roots of numbers that are not perfect squares are irrational numbers. So things with decimals or ugly fractions. So 81 is a perfect square. We know that that is 9 squared. 64 is a perfect square. We know that that is 8 squared, so I'm going to write that down here. 81 is 9 squared. 64 is 8 squared. Now 32. 32 is actually 2 to the 5th power. So that is a perfect fifth, or you could write out the word fifth. That's a perfect fifth. Then negative 125, that is actually going to be negative 5 to the 3rd power, so this is a perfect cube. And that is going to wrap up our day 1 notes of rational exponents.